Good morning, everyone. This is my database management system project. I am DS Somaya. My USN is 1VE22CA400, and I am going to be doing the second assignment on the DBMS system. The contents of this video are going to be: first is going to be introduction, and the subschema, uses of schema and subschema, schema architecture, data independence, and then coming on to the last topic, that is going to be conclusion. The first topic, which is going to be introduction to schema. The word schema comes from the Greek word which means shape and overall structure, or more generally plan. Overall structure or design of database is called schema. In a broad sense, a schema is a mental framework or structure that helps individuals organize, interpret information. It is a cognitive structure that aids in understanding and processing new information based on pre-existing knowledge and experiences. A schema diagram, also known as an entity relationship diagram, ER diagram, or database schema diagram, is a visual way of representing the structures of a database by representing their names, the tables that they belong to, and also drawing the relations between them. It illustrates relationships and dependencies between different entities or tables in database and helps understanding the organizational data within the system. The primary components of a schema diagram include the entities, which are the objects which are present in them. That is going to be the attributes, then the relationships of the entities within the given table, their primary keys and foreign keys relationships. Subschema. The subschema is a subset of proper subset of schema and inherits the same properties that a schema has. The plan, schema, or view is often called subschema and gives users a window through which he or she can view only that part of the database which is of interest to him or her, limiting their visibility to specific tables or data. The subschemas are often used for security and data isolation purpose. It is important to note that the term subschema may not be universally recognized or standardized meaning in all contexts. If you have a specific context or application in mind, providing additional details could clarify the concept you are referring to. Coming on to the uses of schema. First is going to be data organization, which means to organize data in a particular way to make sense and to keep a track of them. Then is going to be data integrity, to maintain data integrity and so that values and entities are maintained and numeral digits are not replaced by characters or vice versa, or there is a consistency between the data structures. Then database design and development, how the database should look like, the tables which are within the database and all the structures which are there. Then is going to be the security, encryption, encapsulation and the different aspects which will secure the database. Then it's going to be querying and reporting. Querying represents important parts of the database where we do specific tasks on the database. Reporting is going to be how we are going to be looking at the data or will be able to view the data and to evaluate more the changes and the edits which have been done. Maintenance of the data, maintenance and evolution represents maintaining the database so that it functions properly and without any errors. Evolution involves the development of database further, and documentation is every single step has to be documented and saved so that if there is an error in the current step, it can be backed off and backstepped to correct the errors. Coming on to the uses of subschema. So data partitioning. Schemas allow for data partitioning by defining subsets of the overall schema. Different users or applications can work with the designated subschema, limiting their access to specific tables or views. Security and access control. Schemas contribute to security and access control by restricting access to a portion of the database or users' applications can be granted access only to the subschema that contain relevant data for their operations. Isolation of data. Subschemas help in the isolation of data, particularly multi-talented multi-application environments. Different entities can operate within their designated subschema without affecting the access set of data to other subschemas. Customization of applications. Applications with specific data requirements have their own subschema tailored to their needs, thus customization without affecting overall database structure. Scalability involves large-scale inbuilt systems that can be scaled depending on the data requirements. Versionization is subschema that can be used for versioning strategies. Different versions of application services work with designated subschemas. This allows for smooth transitions, backward and compatibility during updates. In this slide, we are able to view the schema architecture. We can see the external views, which is going to be the ones which the end user or the operator sees, the conceptual schema, the internal schema that is in the stored database. There are three levels. There is going to be the external level, conceptual level, and the internal level. The internal level is the stored database and the internal schema. Conceptual level is the conceptual schema which is shown to the external viewer through the external view. The external level represents the end users or the users. These can interact to the external view with the conceptual schema, but not directly with the internal schema. Schema architecture. The schema architecture consists of conceptual level and external level, where the internal physical level was first introduced in Charles Beckman in 1975. The motive of studying database architecture provide abstract view of, which means data systems to high details, which allows stored data to maintain in database. The abstraction can be achieved in three levels: physical level, logical level, and view level. The physical level has physical internal schema. Logical level describes what the data is stored in the database, what relationship exists among those data. Then logical level also has logical conceptual view. On to the last part of the topic, that's going to be the conclusion. In conclusion, database schemas serve as a blueprint for organizing, structuring data within a database management system. It defines a logical and structural framework, including tables, relationship constraints, attributes, ensuring that data integrity, facilitating efficient retrieval. A well-designed schema is crucial for overall performance, scalability, maintainability of data system. Provides a standardized way to represent organizing information, allowing for better management analysis, utilization of data resources. The careful consideration and design of database schema are essential for building robust and effective database system that meet the specific needs of applications and users.